Here are the results of two leading open weight models, along with a couple of proprietary models for the exact same prompt. Now, I want you to guess which model is producing which output. The models that I am comparing are Kimi K2 and Qwen 3 with the latest update, and one of them outperforms the other on all of the leading benchmarks. But the benchmarks don't always show you the full picture. Back in April, Qwen released Qwen 3, which was their first hybrid reasoning model, which meant you could use the same model both in thinking and non-thinking mode. And almost all the frontier labs are doing this. But turns out you don't always need a hybrid thinking model. Sometimes you just want to have a dedicated reasoning and a non-reasoning model. So today they released Qwen 3 255B with 22 billion active parameters, which is based on the exact same Qwen 3 model, but now you have a dedicated model that is for thinking or with reasoning capabilities, and then a non-reasoning model. And the performance of this non-reasoning model is currently state of the art on several different benchmarks that they have shared. For example, this is the new version compared to the previous version if you disable thinking. And if you look at it, it outperforms everything else. Now, the interesting thing is that they decided to compare it directly with Kimi K2, which was the leading open weight model released last week. And even interestingly enough, if you disable thinking in Opus 4, this new model is able to outperform even Opus 4, which is pretty impressive. Now, for me personally, the most impressive thing was their RKGI score, which is the best out of any non-reasoning model to date. Even if you disable thinking on Claude 4, it's only able to get to 30%, whereas this one gets to 41.8, which is pretty impressive. And I think this is specifically looking at ArcAGI 1. Another interesting capability is its coding. So this specific column represents Kimi K2, which is supposed to be the best open weight coding model out there. Now, it outperforms Kimi K2 on these two coding benchmarks. On the Aider polyglot, it's pretty close. So that got me thinking, why not directly compare this new Qwen 3 with Kimi K2? And I'm going to show you some results right now. Now, although this model is a non-reasoning model, but in certain reasoning tasks, you can actually see that it acts like a reasoning model. Okay, so the model is available on Qwen Chat, but you can access it. They actually need to work on the naming convention. Okay, so we'll start off with a very simple task, which was just create a website with 25 legendary Pokemons, include their types, lore snippets, and images, right? Now, this is the task on which actually failed. So here's the website that it created. Turned out that I think it's not able to pull the images properly. For reference, here's the website that was created by Kimi K2, which looks pretty nice. And even at the end of the website, it put this disclaimer, which was a pretty nice touch. Actually, Qwen also did the same thing. Now, on to some more complex stuff. So here, this is a variation of the viral bouncing ball in a hexagon. So in this case, it has to produce 20 balls bouncing inside a heptagon, which is spinning. So it's a pretty complex prompt. Okay, so here's the output. It actually nails it, which is pretty impressive because even some of the bigger models are not able to keep track of all of these 20 balls. The best performance I have seen so far is probably from Claude 4 and even the Claude 3.7 Sonnet. Now, for reference, here's the output from Kimi K2, which is also pretty impressive. Especially, I like that when the ball comes from the middle, you see a lot more realistic scattering of these balls. Now, in some cases, I have seen that some of the balls will just fell off of the edges, but seems like I'm not able to reproduce that. Oh, actually, that just happened. Although visually, I think this looks much better. This next prompt is a lot more complex and actually requires a really good understanding of physics, as well as there are multiple different layers that it has to produce. Now, in this case, the model has to figure out the planet geometry that it has to produce randomly, then look at the biomes, texture, and add clouds and different things on the planet surface itself. So this is the output from Qwen 3. Now, you'll notice that in this specific case, the rest of the planet's surface is moving, but the main components on top of it are not moving at all. These seems to be land masses which are not moving, but the inner core of the planet is moving, which is not what we want. And then I think it also placed some mountains on top of it, which is pretty neat effect. But you can zoom into it, rotate it around, and it's very responsive. Another thing that I was testing on was the shadow creation from the angle of the sun. I don't think it's doing a really good job at that. Now, for reference, here's the output from Kimi K2, which also looks pretty nice, right? Now, in here, we have the proper rotation that we would expect. And even, I think, around the planet itself, there's this atmospheric layer, right? Now, the problem is I can't really rotate it, but overall, you can actually see the shadows that are forming. Since Qwen 3 was directly compared with Claude 4 Opus non-thinking, so I decided to run the same prompt through Claude 4 Opus without thinking. And here's the output that I got, right? So I would say the details are missing a little bit, but when I use the same prompt with Claude 4 Opus thinking enabled, here's the output that you get, right? So a lot more responsive, and it's adhering to the prompt much more closely compared to all of the other outputs that we have seen. These prompts are based on something that I've found on X. I think it's from a YouTube channel called Feature Crew. I'm going to put a link to them in the video description. Okay, so we're going to do one more test, and this is going to be reasoning capabilities of these models by solving this specific maze. Again, this is based on Feature Crew prompt. So you actually can generate mazes of different sizes, and then if you simply click on copy prompt, it's going to copy this maze plus some text instruction as well. Now, this is where I started seeing some very interesting behavior, both from Kimi K2 as well as from this new Qwen 3 model. Here's the prompt, and this is the output from Qwen 3. So it's basically going through each and every turn and then updating the path that it's going to take, right? And just like a reasoning model, you're going to see things like this. So it says, wait, there are only 3 internal, these bars or walls visible. Let's count segments. Then here it says, but this line shows connections between cells below row 1. Then it thinks, actually, this line determines whether you can move down from row 1 to row 2. And this goes on forever. And you can see that it's really having a self-dialogue. For example, it says, but this means that the maze is unsolvable. But then it says, but that can't be. Perhaps the coordinates are such that A1 is top left, and so on and so forth. And here's another comment. After much effort, I found a possible path online or by insight. But since I can't, I will stop. And perhaps the answer is this. Then it thinks more, and then it says, perhaps this is the answer. So even though it's not a reasoning model, you can actually see the traces of the chain of thought or the internal monologue. Now, unfortunately, the solution that it proposed does not work. So if we try to plot it, it got it right, I would say, until this point, but then I think it had to take a couple of turns to actually reach the solution. On the other hand, Kimi K2 does a very similar thing. So in some cases, I saw that it actually backtracks, which is a very interesting behavior. And it tries different paths, right? So for example, it says final valid path. So this is supposed to be the final valid path, but then it comes up with this one. And here's the final path that it proposes. But if we try to plot that path, it's all over the place. Now, for solving mazes like this, it probably needs some sort of tools where it can interact with the maze itself. But what was really surprising to me was that even Claude 4 Opus in the previous iteration was not able to solve this. But I'm going to try it one more time. So we're going to disable the extended thinking, and we're going to pass this to Claude 4 Opus. Okay, actually, by mistake, I enabled thinking instead of disabling it. It's actually thinking right now. All right, so it came up with this. Now let's render this. And it's actually really close, right? I think it took a wrong turn here. But other than that, it's pretty accurate. Okay, so I gave the same prompt to O3 just to test, And O3 actually decided to start using tools. So it is writing Python code and doing breadth first search. Okay, so O3 took about 3 minutes 20 seconds. And here you can actually see that using the code interpreter or code execution capabilities, it came up with this solution. Now, the moment of truth. And yeah, it actually works, which is pretty awesome, right? So it actually shows the importance of tools that an agent have access to, and it makes it a lot simpler compared to if you just want to do it in your head. Now, coming back to Qwen 3 model itself, it seems like it's a pretty decent model. I personally don't know whether we can call it state of the art based on this limited test, but do check it out and let me know how your experience is. Also, I'm personally really curious why they couldn't just retrain this hybrid model, because this is a large enough model, and I think if you retrain it on higher quality data with better RL, you probably will be able to gain more performance out of it while preserving this hybrid capability. But it's very interesting to see that they went this route of two dedicated models, and seems like that's going to be their strategy moving forward as well. So let me know what you think and how your experience is with this Qwen 3 non-reasoning model. Anyways, I hope you found this video useful. Thanks for watching, and as always, see you in the next one.